Okay, so besides entities, another very important structure or concept in the ER model is called the relationship. In this page, we show a very basic relationship we can define for the entities. It's called a binary relationship. So in database systems, the relationship among entities is defined based on the product among sets. So if we have learned this from the discrete mathematics, you should know we can compute the product of two sets. So I can show you an example first. Let's assume we have two sets. We have two sets. Let me use a larger font for you, maybe 50. We have two sets. Set A equals to 1, 2, 3, 4, and set 2 and set B equals 2. We can use some other characters instead, like A, B, C, D. Then the question is, what will be the product between A and B? In other words, so we use this X denotes times B. If we have learned this from discrete mathematics, we should know that A times equals to all the potential combination pairs of the elements from the two sets. Like for this example, we have A times B equals to what? First of all, A times B is still a set, right? It is still a set. And what is inside this new set? It will be pairs. Each element is a pair, right? We have lots of pairs. What is inside this pair? The pair will be a combination of the elements from A and elements from B. For example, we have 1A, together we compose a pair. And we have 1B, it will be a pair. Let me write down them all for you. And 1C, it will be a new pair. And 1D. And put them in the center part. Let me reorganize this. And besides the elements from by combining 1 with all the elements here, we can also combine 2 with A, B, C, D. Therefore, we have some more pairs inside A times B. However, we can change this to 2 instead. And we can also have 3 combined with A, B, C, D and 4 combined with A, B, C, D. We can also write down them here. It's 3. And we can have 4 here. No, we have one extra. We can do this one. Okay, then it will be the product between A and B. This is what we learned from the discrete mathematics, right? And for our database systems, we can define a relation between A and B. For example, we can name this relation as R. Its relationship. This is what we know from discrete mathematics, right? And for our database systems, we can define a relationship between A and B based on this product. So we can denote this relationship as R. R is a relationship between A and B if and only if its relationship R is a subset of A times B. So this is the definition for a relationship. Okay, so welcome back to the slides. So in this page, we show the definition as well as some examples of relationships we can define in our database systems. So we can define the mathematical definition as follows. If A, B are two sets, then a relationship R is a subset of A times B. We also have an example shown here. Let's assume we have A equals to 1, 2, 3, B equals to A, B, C, D. Then we can know the product between them, right? According to our example we showed before. Let's assume we have another set, which is R. R equals to a set with 3 elements, and each element is a pair, like 1A, 1C, 3B. And then we can define R as a relationship between A and B. And this relationship connects the entities between these two sets, which can be denoted by the lines as shown here, right? This is a mathematical definition and representation of the relationship. And at the bottom, we also have an example of this mix as a relationship between products as well as components. If two entities are connected by this mix as a relationship, then we can know that this component makes this product. And we can also provide you with some examples. Okay, so in this page, we show an example about this component product as well as the mix. Let's assume we have a component set. It covers Apple, Microsoft, and Tesla. As to the products, we have iPhone, Surface, Model 3, and GeForce RTX 2080 Ti. And we know that the Apple makes iPhone, Microsoft makes Surface, and Tesla makes Model 3, right? And we can define a mixed relationship between them as shown by here. We have Apple, iPhone, Microsoft, Surface, Tesla, Model 3. It denotes the relationship between the company and the products, according to our definition, right? So, and it is also correct because it is true they do make these products in the real world. However, we also show another kind of relationship at the bottom. For example, we have Max Prime, Apple, GeForce RTX 2080 Ti, Microsoft Surface, Tesla Model 3. According to the definition we showed before, we know that this is also a relationship between company and products, right? Because according to the definition, it is true. Even though Apple doesn't make the GeForce RTX 2080 Ti, it was made by NVIDIA, right? But according to the definition, we know this is still a relationship between a company and a product, even though it may contain some wrong information. So therefore, both max and max prime, they are both a relationship between companies and products, according to our definition.